So embedded vision by itself is really an ongoing trend.
And I think it becomes obvious that probably not every company or user can benefit from embedded vision unless they get and consider more than just the cameras.
Welcome to a new episode of our inVISION podcast, 5 Questions To. Our topics are image processing, machine and embedded vision, AI and metrology. My name is Peter Ebert, Editor-in-Chief of inVISION, and I'm happy to have you here for a new episode. In the latest episode of the inVISION podcast, 5 Questions, we delve deep into the fascinating world of embedded vision cameras. Join us as we speak with 2 leading experts in the field, Momchil Binev, Senior Product Manager for Cameras and Software at the Imaging Source, and Jan-Erik Schmitt, CEO of Vision Components. Hello, Jan-Erik. Hello, Momchil. I'm happy to have you here at our inVISION podcast, 5 Questions. Today we will talk about embedded vision cameras. What are the differences? What are the trends? And I would like to start with the first question. How does an embedded vision camera differ from a classic machine vision camera? Maybe Momchil, you can start.
Yes, thank you very much. Well, we should not actually compare typical machine vision cameras, for example, with GIGI or USB 3 interface, with embedded vision cameras with MIPI, FPD link, or GMSL interface. The first ones typically come with an FPGA and microcontroller and perform a lot of pre-processing directly on the camera. Embedded vision cameras on the other side are optimized for cost, size, real-time performance, low power consumption, and any pre-processing is done on the system on chip, for example, on the ISP or in software, which means it's rather a question of having the right know-how and achieving the right trade-off to get comparable image quality and performance with embedded cameras or the complete setups eventually. And I think it becomes obvious that probably not every company or user can benefit from embedded vision unless they get and consider more than just the cameras. And this is what the imaging source offers.
Jan-Erik, what differences do you see between an embedded vision and a machine vision camera?
I think so. What Momchil said already is pretty similar to how we see it. So mainly he said, yes, there's this GIGI vision and USB 3 vision in comparison to the embedded platforms, which is, of course, mainly MIPI, GMSL2, or maybe FPD link. I would also maybe make an additional differentiation. So nowadays, I would see 2 different approaches. So the first one is using camera modules that are offering the MIPI CSI2 interface, because of course that's, as Momchil said, that is quite suited because it has less electronic components, because of course you can base these MIPI camera modules on image sensors that already natively offer the MIPI interface. So this is of course then quite lightweight, and you then have a quite bright choice of your embedded processing units, because most of the modern processing units are already offering the MIPI interface. And these can be, of course, CPU-based or FPGA-based, or a combination of a GPU and CPU or TPU and CPU, etc. So that interface makes it also quite flexible then in the choice and makes it quite easy to find a matching processing unit for the different application. The second approach that we are also in, as we are in the embedded segment since 1996, is an approach which is a bit, which is the most efficient, optimized one to design an embedded camera, or maybe we can call this an embedded camera system, is that it features the image sensor, but also the processing elements in one single unit. So that's what we have done with one of our products, which is called the Pico Smart. So this is a board that has the same size of a MIPI camera module, but it comes already on board with an FPGA and a single core ARM CPU. So both are integrated onto one small board. And of course, this is even quite a huge difference between GIG-E or USB vision cameras, because you put everything on one board. So this would just be one step further to the MIPI, which offers great flexibility, and just one step further in integrating on the same very small footprint, the processing unit as well.
Thanks. And what are the current trends in embedded vision cameras? Maybe Jan-Erik, you like to start now?
Yeah. So what we see is a very strong and still heavily growing demand for the MIPI CSI2 camera modules on the customer side, but also in parallel, many new image sensors that are coming on the market, they also offer the MIPI interface directly. This is, in our opinion, a big ongoing trend in the embedded vision market. And with this very quick evolution we see since now a couple of years of the embedded vision market outside of the traditional industrial machine vision segment, which is of course also heavily powered by AI-based applications. So embedded vision by itself is really an ongoing trend that needs different types of embedded cameras. The second trend that we see is that we get requests from customers that have the wish, let's say, to embed or optimize even further. And that's more or less based on these requests, we developed this, what I said earlier, this PicoSmart camera system. And that's also the reason we're working on expanding this portfolio of fully embedded camera systems in near future.
And what trends does the imaging source see for embedded vision cameras?
Well, speaking of trends, I would actually not say that there is very many technological news regarding embedded visual cameras themselves. Of course, considering the new sensors, we definitely see new sensors coming out almost all the time, and they always promise to be better, faster, more cost-effective, because it's what the market requires eventually. Of course, we see some hype around AI sensors. The question is, what expertise and efforts a user must consider in order to really benefit from AI sensors for specific applications. Otherwise, a trend could also be considered, for example, the right time for better adopting of already existing interfaces into a kind of trendy applications like AI or IoT, robotics, automotive, agriculture, drones, or so on. So next to MIPI and FPD-Link, we definitely see some better adoptions of GMSL2 cameras in the last years, typically with IP67 protected housing, because it's about outdoor applications. I think just like Jan-Erik said it, but I will see it in a different way. I think our customers are not looking only for the cameras. They really look for, let's say, kind of complete hardware designs for a given platform. Let's say for NVIDIA or NXP, and reference design contains not only the camera, not only the cable, contains the system on chip, it contains a carrier board also, a software package, and so on and so on. So this seems to be a kind of trend that customers identified in the last years. So looking only at the cameras is typically not sufficient.
Is spectral imaging, something like hyperspectral imaging or SWIR, also something for embedded vision systems, or not now, maybe in 2 or 3 years? What do you think?
I don't see it actually right now. I think all these new standards and technology typically need some adoption time by the industry and by the customers. I think we are right now in this phase, and this phase could take like maybe 3 to 5 years, maybe even longer, so that the technology is very well adopted and affordable. So it's not only the technology, of course, we always have to consider the prices. If the prices for given technologies are affordable and acceptable by the industry. So I think it's still not the case, and that's why we speak about niche markets right now.
Yeah, so maybe I can also, because that was a very good point. So Momchil, you said new sensors are coming out, of course, more or less every couple of months, and they are all promising the revolution in image sensors. But we all know it's a very good evolution, and it's nice, of course, that you get new image sensors all the time. But the question now from Peter with hyperspectral and SWIR, that was a very good point from Momchil. Because if you're talking embedded, I mean, the embedded technology, that's something that is quite settled. But then if these type of sensors are coming out, and then you would like, so we got a few requests from customers that were interested in having SWIR embedded, so to have an embedded camera that they can connect to an NVIDIA board, for example. But then most of the time, or very often, when customers think of embedded, very quickly the first or second thought is saving money. And then if you would like to make a solution with a SWIR sensor that costs, let's say, quite a lot of money. The difference between having an embedded solution or a non-embedded solution. So the difference is very small. So Momchil is completely right. So with these type of applications, this will take time, and it's this chicken-egg problematic. If the technology itself is very high price, then the will really to invest in developing your embedded system, which is always a bit, or very often a bit more, let's say, investment or time needed compared to a standard camera connected to a PC, then the will is not really there anymore. So the price and market penetration capabilities, these are two things that have to go together well. So he's completely right. These type of things will take a couple of years. And I think it's mainly based on the pricing, if it really will find its way into the embedded segment.
Question 3. What does a user need to consider when selecting the perfect embedded vision camera for his application?
I'll pick it up. Well, to speak only about cameras is not that reasonable, I think, unless the user has all the know-how to develop himself the drivers, the career boards, to utilize the ISP on the SoC, and so on. In my experience, this is almost never the case. So this said, I would rather speak about what else the user must consider besides selecting the right camera and the right interface. As I mentioned already, the user shall consider selecting the right system on chip or processor, because this is important for the image processing. He must find or build the right career board with all the I/Os and interfaces and power supply and so on. He must consider customizing the operating system with the right board support package and camera drivers. He surely must make use of some software frameworks like, OpenCV or GStreamer, or some proprietary networks frameworks, like Halcon maybe. But typically, users decide for open source when it's in case of embedded, and this is very important because eventually the user wants to do some image processing and get results out of the images. So taking all in all, it's a complex process, and the best way to go, in my opinion at least, is to cooperate with technological partners who typically take care of most of those components and challenges and provide a kind of, let's say, complete solution which enables the user to focus on his core know-how. And typically the core know-how of an OEM is to build the complete system eventually. So, and this is, by the way, exactly the case with machine vision. And this is what the imaging source wants to offer also with embedded vision. A complete system which enables the OEM or the end customer to start building his solution.
And Jan-Erik, what do you think are the important points?
Yeah, I think it's very similar, even if I think that on the customer side, we may have a bit already more customers that have more know-how in the embedded field, as we are offering, let's say, embedded solutions since the beginning. But in the end, Momchil is completely right. So on our side, I would see, let's say, 3 to 4 main blocks. The first block, Momchil even didn't mention it because this is exactly the same to a standard traditional machine vision camera. But that's something that we expect that our customers know how to choose it. So it's, do you need a global shutter or global reset or rolling shutter? Do you need a camera sensor that has to have a certain sensitivity at a certain wavelength? So this is completely the same, talking embedded vision camera or traditional camera. Then the second big thing is, but this what's completely mentioned by Momchil, is that an embedded vision camera, you need a bit more than only the hardware. So you need some, let's say, firmware, driver, software support for the combination of what you want to use. So the MIPI module, the processing board, and the carrier board. So this all have to work together. So this can be a big task to get the MIPI module running with a specific setup. So that's why you have to look at what is available as standard drivers, and do you have this capability that in-house, or do you need this, let's say, development support to adapt this to your application setup? And the third point that I see is also you have to look at the connectors. So of course, do you have a very short, let's say, cable length between the MIPI module and the processing board? then you can work with an FPC, but then also there you have to check what kind of connectors comes from the MIPI side, what kind of connectors available on your carrier board or on the processing board. So these three main blocks is, of course, the sensor itself has to match the application, then all this software firmware support, and purely the connecting elements regarding the cables. So that's the three big blocks that we see. So the let's say optical, optomechanical, software firmware, and the connector issue and cable length.
Thanks. Now we're going to question 4. Are there any news about MIPI for embedded or machine vision applications? And are there currently alternatives to MIPI for embedded vision systems?
So I will pick up this one. Well, to be honest, I think it's not completely right to limit embedded vision to MIPI CSI2 only. Embedded vision could also be a board-level camera with GIGI or USB interface. It's always a question of what the customer actually requires eventually. And when longer cable lengths are required, users anyway go for serializer and deserializer technologies like FPD-Link 3 or GMSL2, which are based on MIPI. So yes, MIPI itself evolves and comes up with updates for sure. Just like all other interfaces and protocols from a higher level perspective, and this is the perspective of the customers, I think the current state-of-the-art technology covers at least, I would say, 90% of all customer requirements. So any updates and improvements in regard to MIPI are welcome for sure, but I think they will have the adoption time at the customer side, as always.
Yeah, I will take it over. So I had regarding the MIPI news, I would then really recommend watching the keynote of the last inVISION days from last year, December 4th.
Thank you.
Because here we had somebody from the MIPI organization talking about news and developments in MIPI. But as Momchil said, so right now we have a lot of tasks, a lot of customers adopting what we have right now within MIPI. The other point, of course, I see it in a slightly different way. So as we're in this embedded thing for many, many years, for us, embedded is always when it's really embedded. So as soon as it goes to detach, let's say, the head or the camera part from the processing part, then for us it's always difficult to name this an embedded solution. But we've seen that, of course, also the nomenclature, let's say, slightly changed over the past years. So that's why, in our opinion, there's no real one-to-one alternative. Of course, you can use a USB camera or a GIGI vision camera, or even with the GMSL2. But for us, it's not a one-to-one alternative, because when we talk embedded, it should really be, let's say, all together. So that's why it's slightly different way from our side. But regarding news, I think it's a lot of job to get people to use the actual MIPI offering and to generate really a lot of new applications. So the real news are, for us, let's say, secondary right now.
Thanks. Now we're skipping to our last question already. In March, the Embedded World Fair in Nuremberg will take place. What new products will we see from your companies there? So maybe Jan-Erik, you will start?
Yeah, so the first thing is, yes, it's March again. Time is going by too quickly. But this year we're going to show a smaller and more cost-optimized version of our processing or pre-processing units. So we have the VC Power Sums. That's an FPGA-based board that can be put directly into the MIPI data stream to process image data. So the main idea is it makes a lot of sense in applications where you can very well parallelize the image processing of the image data, as the FPGAs are perfect fit for this. And this thing can reduce the all-over power consumption and gives you more flexibility in the choice of the processing board that will run the main application and the user interface. So this is where we have a big emphasis this year on this pre-processing units. A second one, which is even smaller. So we have made an additional FPGA pre-processing board that is exactly of the size or the footprint of our small MIPI modules, and that can directly be attached to the MIPI modules in order to generate a very compact stacked, let's say, camera sandwich. And the first real-world application that we're going to show is a fast barcode detector IP core. So that runs in real time in the MIPI data stream, and it sends the barcode position in parallel to the image data, but still using the MIPI interface to the main application board. So as you can see, I've been telling earlier that we see, in addition to the pure camera modules, also this more compact and optimized products and platforms to further optimize and embed features on smaller footprints. So this is our, let's say, biggest point this year on the embedded world.
Thanks. And what news will we see at the Imaging Source booth?
Well, the Imaging Source is going to showcase some really cool new things, just like vision components. For example, our new high-resolution sensors with MIPI CSI2 integrated on our complete NXP-based reference design. We're also going to demonstrate our new NVIDIA Jetson Orin reference design, including carrier board, multi-camera setup, and so on. And last but not least, we're going to showcase also our upcoming GMSL2 cameras with IP67 protected housing. Stay tuned and stop by the Imaging Source booth. And we're competitors, but I also will stop by at the Vision Components booth for sure.
Yeah, for sure, as we did last year. But as Peter said, I think competitors, yes, but I would name it co-competitors, because I think the market for embedded vision, also the difference in applications, so the market is quite huge. And as you said, what we see is that not many people yet have in-house all these design capabilities, and also what we see is we get requests from customers which are very well in the embedded field, so operating system, Linux drivers, so these type of things is working very well. But then there can be a lack of, let's say, standard things regarding the image sensor choice. So sometimes, depending on the markets, they see the cameras as some kind of sensor, giving some data, but there's no real knowledge about what's happening. What is image acquisition? What is a rolling shutter? What is a global shutter? So that's why there are different markets, so many opportunities. So that's why it's very nice to have, let's say, some co-competitors, because I think everybody is finding the applications and different types of customers. So I think that's a quite nice time to being in this market segment.
Yeah, Jan-Erik, I see it very positively. Basically, competition is driving us forwards, and customers benefit from that. So I like to be in competition with Vision Components and similar companies, because it's a kind of fair competition, and we are, I think, targeting slightly different customers and applications, and that's fine.
Yeah, definitely likewise. So for us, it's really, we are always happy if the embedded vision is growing, because we have been for many years in this segment, but it was different because we were the niche in the niche, and now this embedded gets definitely more emphasis. Of course, this is based on a lot of things that has happened in the let's say consumer markets with mobile phones and tablets, all the processing units that came up over the last year. This opened up all these possibilities are really based on the processing units that are available right now. I mean, this is really a great time, and I see it same like you said. Competition, I think, is driving everything further, and also brings developments from the consumer market into the, let's say, the semi-industrial market or industrial market. And I think that's also a good thing to have these, let's say, two markets or two or three markets more or less wobbling together right now.
So Momchil and Jan-Erik, thanks a lot for this conversation. I will see you later at the Embedded World.
Yep.
So thanks a lot and bye.
Thank you.
Thank you.
Bye-bye.
If you would like to find out more about inVISION, please register for our inVISION newsletter at invision-news.de/news, become a follower of our LinkedIn channel inVISION News, or find out about our webinars at invision-news.com/TechTalks. I look forward to welcoming you to our next episode of our inVISION podcast, 5 Questions 2.